Welcome back to Science. Let's take a look on KTAL LP, Las Cruces, New Mexico, 101.5 on the FM dial. We've been talking about a whole bunch of things. I'm your host, Ben Skuchik. With me in the studio today are John Nelson and Craig Ricketts. They have experience in space and filters, and that brought us to many interesting things. On the last segment, we ended up talking about, let's see, where did we leave off? That was about
the question was
the computers
right.
on spacecraft, that
right.
they tend to have old technology with much bigger transistors that are more resistant to radiation, because in such a big area you're less likely to have a cosmic ray or anything knock out the whole bit and change the program. Okay, so the question was, could they put more shielding around a more modern circuit? And I brought up this idea that our friend David Anderson told me. David is retired now, as I am. Actually, we're all three retired, all four. And he used to work at Fermilab in Batavia, Illinois. I met him when we were all at Los Alamos Labs. But David brought up this idea of space travel by humans, interplanetary travel. So what do you need to go from Earth to Mars? Well, you need a lot of time. And that's a lot of time being exposed to radiation, whether it's cosmic radiation or solar flares. And of course, NASA and everybody else who wants to work on interplanetary travel is very worried about radiation shielding. The problem is, if you put enough shielding to, say, meet, I don't know, OSHA standards, there's no OSHA standards for space, but there are OSHA standards for radiation on Earth. But if you want to get down to what are considered safe levels, the shielding would be so thick you couldn't lift that rocket. Okay, so David said the secret is you don't put much shielding there at all. And how does that work? Well, what he said is, if you've got partial shielding and a cosmic ray comes barreling in with tremendous energy, it creates a cosmic ray shower of ionizing radiation. And that's worse than being hit by the cosmic ray directly, because everything else has been multiplied. And he said, that would work, but I'm not going to tell NASA because I think interplanetary travel is a stupid idea. So even if other people don't agree with him, that would be interesting to try to get that idea across. Now, we had also talked informally here in the studio about how big a spacecraft, how heavy a spacecraft can you get out there? If you have to start with something like the rocket equation of Tsiolkovsky, and this was before there were any rockets. In 1902, he came up with the rocket equation. So you're in free space, so you don't worry about your atmosphere and gravity and so on. And you want to say, how fast can a rocket get going? And basically, you take the exhaust velocity of the chemical propellant and you multiply it by the natural logarithm of the initial mass divided by the final mass. Okay, so suppose you've got a 100-ton rocket and you burn out fuel that amounts to 90% of that mass. So you've got 10% left. So the log of 10 is 2.3. So you can get going 2.3 times as fast as the exhaust velocity of your gases. That's not good enough for any of the chemical propellants we have, and that's why we have stages on rockets. So now we've got some people who are getting really ambitious about putting really big rockets out there. So one way to get around the chemical propellant limitation is just make a bigger and bigger rocket so you can lift a bigger and bigger payload. So the Falcon Heavy rocket by Elon Musk's company, SpaceX, is, as you say, John, considering 50 to 60 tons as their delivery?
Yeah, and their first launch is going to be here early in February. He's made the statement if it clears the tower, he'll consider it a success.
Well, this is a monster rocket, isn't it?
Yeah, 27 engines or 24 engines or something.
27 engines,
Yeah.
right, but the height is like 110 meters or something
huge.
crazy.
Yeah, it's 3 Falcon 1s lashed together, basically.
Right, and each one of those is a pretty tall thing.
Yeah. So we'll see if he can get 54 tons. His first launch is he's launching, well, he's got to launch something. So I put it, he's got a red roadster that he's going to launch towards Mars, if he can do
So this is his interplanetary version of the Tesla?
it. Right.
Right. So Elon Musk said that he would love to die on Mars, just not on first impact. So he wants to design something that'll get everybody there safely. Do you remember how many people he said he wants to be on the first mission? And that sort of gives you the scope of how much weight we're talking about. They have to have all their supplies to keep going on Mars, at least for a while, right?
Yeah, it's a lot of people. I'm thinking in the terms of 100, but I don't know that that's right or not. That's way downstream. I mean,
Yeah. How do you do this, right? Because first of all, you've got to get some people there, and then you've got to have supplies so that they can build a living environment and stuff to extract resources from the planet and grow food and so on. It looks like a logistic
nightmare.
So are you going to be in on this, John? I mean, you
No,
were on the Apollo 11 mission.
I want to watch.
You want to watch. Well, let's see. What's the time delay between the Earth and Mars? It depends on where they are relative.
Yeah, I think a good average, like six months or something. I mean,
No, I don't mean the travel. I
Oh.
just mean the communication.
Oh, I don't know.
So they're an extra, well, if I use old English units, 47 million miles. What's that? Let's see, times 1.6, about almost 75 million kilometers further out. And then what's the speed of light is 300,000 kilometers per hour. That's a third of a million. So it's 250 minutes or something.
You know, I don't know.
Yeah, anyway. I think I've blown that. I think it's seconds. But anyway, it's a long time to communicate. Just like during the Apollo mission, there was this long delay.
Right. But for Mars, yeah, they're going to have to be independent. I mean, there's control from the ground doesn't make any sense.
Right, but then you want to listen.
Right. I want to.
So you're going to have these
I hope I
long
don't hear a
delays.
crash. But
Right. So they'll have a call-in session, and John Nelson, you're on the line. And you make your question, and then people sit back for 10 minutes or whatever, and then you get your answer.
Well, wasn't there an interesting recent development about them having documented layers of moisture in the Martian soil?
It's even wilder than that. They've apparently discovered an ice cliff that's 100 meters tall. Yeah, in one particular area. So I don't know how that ever stayed there. I mean, if you look at the moon, there's ice at the poles, but this wasn't at the poles, because you're not going to get to the poles on Mars if you land somewhere where there's enough light for you to be warm. So I'll have to look up, what location they actually found all this stuff in.
But if it is true that water might be much more readily available than initially anticipated, that might be another reason or another resource that would be available that wouldn't have to be transported from Earth.
Right, yeah.
Right.
So, what do you have to get out there? You have to get water for all sorts of biological and other functions, and then you're going to need lots of minerals for structures, because you can't carry everything.
Mhm.
Isn't this like that puzzle, like who can you carry on the boat across the river? So you got to get everybody there, the predators and the prey and so on, But it's almost like that. How much infrastructure can you get there and have people actually putting it together so that the other people can come? I haven't seen a plan laid out.
So initially, only vegans dare apply.
That's right. Yeah. Yeah. So yeah, if you bring that up, if you have chickens, you get about a third of the original biological energy of the food as chickens. If you do beef, it's about 1/8. But then you better take vitamins, because vitamin B12 is really short in vegetable matter, and you can have bacteria in your gut making B12 for you. Maybe not enough, but it's with microbes, and there's no microbes on Mars other than the ones you bring with you. So you better have the right ones.
Right.
Don't take doxycycline the way I did to go to Vietnam, because I couldn't stand. I would get sick with the other antimalarials, and that wipes out your gut microbiome. Bad idea. But it was worse than that, because we didn't need the antimalarials. It turns out there were no mosquitoes anywhere that we went to, even in the mountains. So it was pretty wild. We got about a minute. Let me just make a quick announcement. This is KTAL LP FM. This show is every Tuesday at noon, 12 to 1, on 101.5. We often have guests. We go over all kinds of science. Do you want to make any closing notes, John and Craig?
Well, I'd just like to thank you, Vince and John, for allowing me to be here and participate in these fascinating discussions.
Thank you. This has been a lot of fun. It always is.